Uranus is often described as a planet discovered by mistake. It is a memorable phrase, but it gives the wrong impression. William Herschel did not point his telescope in the wrong direction. His instrument did not fail, and his observation was not careless. He simply found something he had not been searching for. On March 13, 1781, Herschel was studying stars from Bath, England. He had no reason to expect a planet beyond Saturn. Yet one object in his telescope did not look like the surrounding stars. That unexpected encounter began the discovery of Uranus, but the object did not become a planet in a single night. In fact, Herschel was not even the first person to see it. In 1690, English astronomer John Flamsteed recorded the same object as a star, cataloging it as 34 Tauri. James Bradley and Pierre-Charles Lemonnier logged it too, decades before Herschel. Professional astronomers had seen Uranus repeatedly and missed it every time. Why? Uranus is faint, barely brighter than the stars around it, and it moves painfully slowly. Uranus takes about 84 Earth years to complete one orbit around the Sun. Without comparing precise positions over time, it simply looks fixed. Astronomers were staring at a planet through the lens of a star catalogue, and it never occurred to them to look twice. So what let Herschel notice what trained astronomers had missed? Herschel was a German-born musician turned self-taught astronomer, and astronomy was no hobby for him. Dissatisfied with commercial telescopes, he built his own, grinding mirrors from speculum metal, an alloy of copper and tin. The telescope that found Uranus had a 6.2-inch mirror, sharp enough to catch faint light and register the smallest differences in appearance. His sister Caroline became an essential collaborator in his telescope work and record keeping, though there's no confirmed evidence she was present for this specific observation. And Herschel wasn't randomly scanning the sky that night. He was running a planned survey near the star H Geminorum, part of a study on stellar parallax, when something unfamiliar caught his eye. Between 10 and 11 that night, Herschel spotted something visibly larger than the stars around it. He didn't know he'd found a planet. He just knew it looked wrong. That size difference could have been an optical trick, bad focus, atmospheric shimmer, a flawed image. So Herschel tested it. He'd first noticed it at 227 times magnification. He pushed the power to 460, then 932. Here's why that mattered. Stars were far too distant for any 18th century telescope to resolve into visible disks. They stayed pinpoints no matter the zoom. This object didn't. Its disk kept expanding as the magnification climbed. That weakened the idea it was an ordinary star, but it didn't prove it was a planet. Comets could behave the same way. Herschel needed different proof: movement. On the 17th of March, he checked again. Its position had shifted against the background stars. This wasn't a fixed star. It was moving through the solar system, but in 1781, that didn't scream planet. No new planet had been found since antiquity, and moving objects were routinely classified as comets. So Herschel reported it cautiously. His paper to the Royal Society, read on April 26, 1781, was titled "Account of a Comet." He wasn't hiding his uncertainty. He was reporting exactly what the evidence showed. Once the report went public, astronomers across Europe started tracking it. Neville Maskelyne, the astronomer royal, urged patience over a premature conclusion, and as more positions came in, mathematician Anders Johann Lexell began calculating an orbit. The result: a distant, nearly circular path far beyond Saturn, nothing like a comet's trajectory. Combining its visible disk, its motion, and now its orbit, the picture was unmistakable. This wasn't a star, it wasn't a comet, it was a seventh planet. So if Flamsteed saw it first, and mathematicians confirmed the orbit, why does Herschel get the credit? Because discovery isn't the same as first sight. Flamsteed and the others logged a star. Herschel recognized something different, tested it, tracked its movement, and shared honest, uncertain evidence for others to check. The wider scientific community did the rest, which is exactly why those older sightings are now called precovery observations. Evidence recorded years earlier, understood only in hindsight. By 1783, Uranus was widely accepted as a planet. Herschel received the Copley Medal, a Royal Society Fellowship, and royal patronage from King George III that let him leave music behind for astronomy full-time. There was still the question of what to call it. Herschel proposed Georgium Sidus, George's star, honoring his patron. German astronomer Johann Elert Bode pushed for Uranus instead, fitting the mythological naming pattern of the other planets. There was no official ruling. International use simply settled it. Uranus won. And its significance went beyond a name. Before 1781, the known solar system ended at Saturn, roughly 9.5 astronomical units from the Sun. Uranus orbits at about 19, nearly doubling the known boundary of the solar system overnight. Its position also seemed to fit the Titius-Bode pattern, a numerical rule astronomers no longer treat as a real physical law. But at the time, it fueled the search for a missing planet between Mars and Jupiter, a search that led straight to the discovery of Ceres and the asteroid belt. But expanding the solar system didn't just solve old mysteries, it created entirely new ones. As astronomers tracked its orbit over time, its observed position did not match Newtonian predictions based on the known planets perfectly. Something appeared to be disturbing its path. Mathematicians John Couch Adams and Urbain Le Verrier calculated where that unseen planet must be. In 1846, Johann Galle pointed his telescope at their predicted coordinates and found Neptune almost exactly there. Herschel had found Uranus by accident through a telescope. 6 decades later, Uranus's own gravity helped astronomers predict a planet before anyone had ever seen it. The sequence connected 2 different forms of discovery. One began with an object that looked unusual, the other began with numbers that did not behave as expected. In both cases, the important step was recognizing that the evidence did not fit the existing explanation. The investigation of Uranus did not end with its discovery. Its rings were detected in 1977. On January 24, 1986, Voyager 2 passed the planet and provided detailed information about its rings, moons, and magnetic field. It remains the only spacecraft to have visited Uranus closely. Despite being known for more than 2 centuries, Uranus remains a comparatively underexplored ice giant. The planet that once hid among familiar stars still marks the boundary between what has been observed and what has truly been understood. Its discovery shows that luck can place an object in front of us, but luck alone does not explain it. Discovery begins when someone notices that a familiar-looking thing behaves differently, tests that difference, and is willing to revise the first answer. The target was accidental. The method was not. And that leaves one final question: how many discoveries remain visible but unrecognized because they still resemble something familiar?